Okay, in this lesson we're going to talk about simplifying what we call radicals. And I'll try to start and move through this fairly slow and conceptually, but you got to understand this is one of the tougher things for students to master and get comfortable with. So don't get frustrated if you don't get it right away. It takes some practice sometimes. What we're going to start by doing is look at some numbers that you recognize already. I call these perfect squares. Okay, for example, 1 is a perfect square because when I take the square root of it, I get a nice whole number. 4 is a perfect square because its square root is a nice whole number. Square root of 9 is 3. Square root of 16, 4. Square root of 25, 5. Square root of 36, 6. Square root of 49, 7. Square root of 64, 8. And that could keep on going. It might be good to list the first 10 or so on your paper, and then you have them to work with. You don't have to constantly think about them. Now these all happen to be really nice, easy to calculate numbers. They're ones you could memorize and do in your head. And what you want to do is memorize these. But what we're going to try to approach now are numbers that fall in between. Notice I went from 1 to 4, 4 to 9, 9 to 16. I specifically jumped to ones that I knew worked out really well, the whole numbers. Well, what if we get numbers that aren't like that? Okay? What we're going to try and do is write them in a different way that at least shows, are there some nice numbers within them, okay, inside of those values. So here's what I mean by that. You might be given something that looks like this, square root of 18. Now, let's think about the different ways. 18 is not a nice number. Okay, it ends up somewhere right in this area, between 16 and 25, but it's not a nice whole value. It would be 4 point something. So rather than get a decimal, we're just going to see if we can find any whole numbers that happen to be in there, any perfect squares. So I'm going to think about 18. 18 is made up by doing 18 times 1, 9 times 2, or 6 times 3. Those are all the factors of 18. Now what I want to know is there a nice perfect square within this? Well, 1's a perfect square, but 1 doesn't really help us write anything differently. Nothing ever changes with a 1. 6 and 3, neither one of those perfect squares, but 9 is a perfect square, so this is the combination I'm going to use. Okay, so 18 is not a perfect square, but 9 is, and 9 is part of that number. It's hidden within there. And we're going to try to take it out. I'm going to write it as the square root of 9 times the square root of 2. 9 times 2 is still 18. So I haven't changed what this means, I've just changed the way it looks. Now, the reason I've done that is part of this solution, part of this number, I know in my head, and the other part I don't. Okay? Square root of 9, I know that one. That's 3. Square root of 2, well, I don't know the square root of 2. It's somewhere up in this area, but it's a decimal. It's actually one of those never-ending decimals we call an irrational number. So instead of getting a decimal and rounding it off and making this answer somewhat inaccurate, I'm just going to write square root of 2, because that's the number that's not nice that I don't know. And 3 times the square root of 2 is an expression that means the same as this, but notice we get to work with smaller numbers. We don't work with a big number like this. And you may not think 18 is a big number, but as we move on, you're going to see some fairly large values there. We would like to write them with as small numbers as possible, and hopefully with one that happens to be a perfect square. So let's try one more of these real quick. Let's say we have the square root of 24. Okay. Well, let's think about what makes up 24. 24 times 1, 12 times 2, 8 times 3, 6 times 4. Now those are all correct. So you're not wrong if you choose a different set than me, but you may not pick a set that doesn't help you, or that helps you out. You might pick something that just doesn't get you anywhere. So let's look at this option now. We've got all these values. 1's a perfect square, but doesn't help me. 12 and 2, they aren't perfect squares. 8 and 3, they aren't perfect squares. When I say perfect squares, I'm talking about these values right here. Notice 4 is on that list. It's right here. Okay. So 4 is a perfect square, so that's the combination I'm going to work with. And I'm going to write square root of 4 times the square root of 6. And 4 times 6 gives me 24, so I haven't changed what it means. Now the square root of 4 happens to be a nice number. That's 2. The square root of 6 is not a nice number. It's a never-ending decimal, so I'm going to write it like that. And 2 times the square root of 6 is the same as the square root of 24, but it's written with smaller whole numbers.